All right, let's get started. Good afternoon, good evening, everyone. And apologies for starting a little behind schedule and for the challenges with the Zoom link today. So this is the last class, and it's great to have you all here. It's a great opportunity for us to touch base on everything that we've learned in the last 9 weeks or so. And for you to ask any questions, we can get clarifications on issues. Today, we're not using the webinar style. So, you're going to be able to unmute yourself at any point in time. Hopefully that makes it more engaging and helps us to get a more free-flowing conversation. But also that means that we're going to ask that you take it upon yourself to mute yourself when you're not speaking, so that we can all benefit maximally from this this session. Again, your videos, you can also turn on your video if you like, and you could also leave it off, whatever preference that you have. All right. So in the last 9 weeks, we've gone through a whirlwind of topics, very quickly done what is essentially a full stats course. At Harvard, for instance, this you will teach this kind of series over several months, right? But we've gone through very quickly, and we've we've done this in fewer sessions. We've had the opportunity to have our labs, SPSS labs, and hopefully this is an opportunity that's going to crystallize the entire experience for you. Okay. All right. So today, what we want to do is talk about variables very quickly, and basic stats methods and regression methods. I want to say that we talked about variables. We talked about variables extensively in the beginning of the class. So I guess for starters, I want to ask that someone tell us about variables. What do you know about the different types of variables?
So Alhamdulillah,
Anyone wants to tell us about variables? What are continuous variables? Maybe that's a better question to ask. If you have unmuted yourself, you can, go ahead.
Yeah. Continuous variables are type of variables that can take on infinite set of numbers.
Okay. So give us an example of a continuous variable that you remember.
Something like the blood pressure.
Something like blood pressure. Very good. All right. Someone else wants to tell us about categorical variables.
Okay, categorical variables could be it could be binary.
Binary, yes.
Where you have yes or no.
Okay.
Or they could have more than one categories.
More than one category. Okay, give us an example.
Like when you're talking about weights, you have underweight, you have normal weights, you have obese.
Okay, that's good. So since you're already talking about categorical variables, don't go yet. Can you tell us the difference between an ordinal categorical variable and the nominal categorical variable?
Okay. Ordinal categorical variables are categorical variables that can be ranked. There's an order.
Yes.
About them.
Excellent.
For example, you have when you're talking of BMI.
BMI.
You have underweight. You have normal weight. Overweight. Obesity. So there is an order to it. Unlike the nominal categorical variable, where it's just binary, there is no order to it. For example, you have sex can either be male or female.
Female, okay. That's a good example of a nominal variable? You know, it doesn't have to be binary. It could be something like maybe colors, where you have red, blue, green, you know, or so that's a type of nominal categorical variable. Thank you very much. That's an excellent response. The other type of variable that we saw, so we saw two other types of a few other types of variables, and one is a count. Does someone want to tell us what a count is? Someone else who hasn't spoken. What's a count variable? Anyone, unmute yourself and just go for it.
Yeah, should I?
Yeah, go ahead.
All right, thank you very much. A count variable is a variable that does not take on a decimal. So for instance, integers like 1, 2, 3, 4, that's a count
Okay,
variable.
what's an example?
An example will be number of participants on this course.
Yep, number of
Say,
participants.
number of cows in, say, a sample, or number of,
Yep.
yeah, something like that.
Yeah, that's an excellent, where you can have half of that
Yeah.
thing. Yeah, excellent. So there is one more question that I have. Someone else wants to tell us what a proportion is. And we're just setting it up and we're going to move forward now. What's a proportion?
Hello.
Yes, please go ahead.
Yes, proportion is simply one variable called the numerator divided by the other one called the denominator.
Yep.
That is proportion.
That's a proportion. Excellent. And so, you know, we think about proportions a lot in research, where it gives us an idea of how something is occurring, right? You might have like maybe the number of patients who have a certain disease, right? Maybe number of patients who have anemia might be out of a total. So you might have maybe 100 people in a sample and 20 of them have anemia. You might say that the proportion of people who have anemia is 20 divided by 100, which is 20%, right? Which is 0.2. All right, so can somebody take a look at this slide, right? We have a slide here and we have a continuous variable height, right? Measured twice among patients patients attending a pediatric clinic. So the question that I have is, what is the difference between these two distributions? So you have two histograms based on the heights, right? What difference do you see between these two distributions? Anyone? Go ahead, yeah.
Okay, I think the one on the left, that's height on day one.
Okay.
Looks has like a single peak, not really a single peak, but then it has like, it looks normally distributed.
It looks normally distributed, yes.
While the one on the, that's height on day two, does not look normally distributed because it has like one peak on, it's shifted to the left.
It's shifted to the left,
Yeah.
yes. What we call that shift? We say it's a
skewed.
Yes, skewed. And so this is a right skewed distribution because, you know, you have the gentler slope is towards the right. Okay. All right. So this is an important setup for everything that we do in the later classes, right? We talked about the variables and we looked at the distribution. And one thing to remember is that the way that we analyze data when we have a normal distribution is different from when we don't have a normal distribution, when there's a skew, right? And you will see that we have methods that have differed based on whether there's a normal distribution or not, okay? So that leads us to the next section that I want to just talk about quickly. And that is comparing means and medians, right? And we talked extensively about different approaches of comparing means and medians, comparing proportions. But in comparing means and medians, the first thing that we said was that what we are really doing is that we are comparing the distributions, right? That it's not